We at what was then Devel had a brilliant framework that we use for many of our systems called LabQT. Some brilliant minds behind that, and with those brilliant minds, we could just ship out pretty darn good systems in well, reasonably short time, development time. It was great. The only thing is that only a selected few understood how it works. So it was fairly complicated, made use of, well, kind of the standard patterns that you would see in object-oriented coding and stuff like that, but a lot of it, and all of it, and all over the place. Which kind of meant that, right, our customers could never own our code. They could own our code. They should do that, but they can do it. If they open it, they wouldn't understand anything. Next problem is when we're growing as a company and employing more and more LabVIEW engineers, well, the threshold for them to learn this was kind of too high. They would open the projects and they wouldn't understand it. So you needed to be rather senior CLA level developer to be able to work with it. Which made us ditch that and go for a much more low-level architecture. We also gone for the DPMH, started up building up a kind of code base for our systems based on that. And during this kind of journey, I kind of realized that this is the case for pretty much all organizations out there, that you will need to find your level of architecture in your code, level that meets your needs, that you're able to do all the things you want to do, but also meets the needs from an organizational level, that there is going to be a reader from your code. And you need to know that when you write your code, that you're actually writing this code for a reader. So that's what I'm going to go through today. Some sort of different levels from the just bare minimum to just adding a few more levels of architecture on it. Actually going to end up on that where we have the dynamic loading of the plugin for doing tasks. Just a little bit background. My name is Martin Peker. Been working with LabVIEW. Well, Martin, you said you've been working with test systems since what, 96?
99.
99, yeah, all right. So you beat me by 2 years. So I'm 2001, but I started with LabVIEW straight away. So in February next year, I've been in the LabVIEW world for a quarter of a century. No, don't really know if that's a good or bad thing, but that's the way it is. I worked for Prevas Test and Measurement, sit in Lund, outside Malmö in southern Sweden. We were previously, until 2 years ago, we were called Devel, and then we were acquired by Prevas. Prevas is a consultancy firm. That's you find them all over the Nordics, except for Iceland. In Denmark, where I had our biggest base in Sweden, quite a few in Finland, and some footprint in Norway as well. Just short about who I am. So yeah, if you're going to ask for my slides later, it's going to be, you're not going to see much. It's going to be code. So what I've done here is I have a kind of made up problem. It's quite common. We see it several times a year. We have a test system. It's a number of tests that needs to run in a sequence. You need to create a report. That's the task at hand for my kind of mock-up test system here. And we're going to look what this test system looks like when you just start from scratch, doing the simplest, and then you realize, all right, we need some better architecture. What does that? What effects does that have on your abilities with your system, but also on the readability and the management of the system? So we go from the bare minimum to some object-oriented code. Obviously, it can go a lot further than that as well. No frameworks or anything like that in this. I just keep it kind of bare metal. I'm going to show you a little bit, some slides from a real example of what it looks like. But yeah, just going to dive into it. So for the simplest version of the system, we have a main VI, and then we have like 3 sub VIs in here. We pass a serial number as an input. There it is. And what we do here is that we measure the current on the signal called AI1. We power our device on, we wait a bit, we measure the current again on AI1, and then power it off. And then we put all of that into a report and save that. So this is, well, there is the lower level. You could have all the code from the block diagram. As you know, that is not recommended. So what we do here is we just call these 3 different sub-VIs. We get the result, we pass it in into an array, and then we create some sort of report. And now this code works when things is just pretty much empty behind this. It's kind of more like the prototypes for the functions that we're looking at. At this level, if this is what the only thing you're doing, it's perfectly fine. As soon as you want to extend this, you're going to run into problems. So just to highlight the problems with this, we have a main extended. We do the same thing, but we do it 3 times over. So instead of these 4 test cases we had, we got 12 test cases, and already it's getting out of hand. So around at this point, we were going to realize that, all right, we need to throw some sort of architecture on our code to deal with this. If this continues, so this is, yeah, it's all there, but it's not very readable. It's going to take you a few minutes to figure out what's going on here. So that was the first level. So where do we go from here? You need to keep the time. Tell me when I'm running out of time. So we start using a state machine just to pretty much a real estate of your block diagram to kind of keep it in one frame. Still the 3 sub VIs, still the main. I still got the main extended there. Open up the main, we look at this. Right, it's getting a bit, well, not coherent, small, I would say, again. So what we have here, it's a state machine. We have an initial case, which is the init. And then that just points to the next case, which is a test case, which points to the next one, which is a test case, which points to the next one, which is a test case. And yeah, all of a sudden, this is going to be a lot easier to extend for those 12 test cases. It's still, compared to the first version, you lost a little bit of readability. You need to go into each test to see what's happening, or each case here to see what's happening. You also added the risk of messing up by passing or having spelling errors for the next case, or passing them in the wrong order and stuff like that, which is not going to be obvious. So you gained a little bit, you lost a little bit. If we extend this to the 12 test cases. Just the same size of it. But faces you when you open it up, it's going to be pretty much the same thing. But you see here, you walk on, so you got standby current there. And then also you got standby current 2. So if you look here, I purposely did not put them in order here. So I got standby current and then 2 and 3, but the test case and the test sequence will go to standby current and then power on and then operating current and power off and then go to standby current 2. Right, so we can keep everything a little bit more together. We added more ways of creating mistakes, and we need to create the readability ourselves by ordering these in the right order. So a little bit more architecture, easier to extend it, but you lose some as well. Now, when you go through these, the question is where you as an organization want to be within this kind of different architectures. So if you work at an organization, let's say that like you 3, 4, 5 developers, they're all at least CLD level, you don't want to be here. I just showed you. You work in an organization where you're hardware engineers, you open LabVIEW once a month to do a change, you might want to be here. That also is good to remember that if you, as a senior developer, I mean, everyone here is kind of here on their free will, spending 3 hours on a Thursday afternoon to be on a LabVIEW user group. We're kind of investing time and effort in this. Sometimes we will write code to people that just opens LabVIEW twice a year, 3 times a year. They will need to be able to read your code and understand your code. So if you have that kind of audience to your code, keep that in mind when you write it. Right, so what we saw there is that we have a sequence of test steps, and we need to take care of the order. Next step, obviously, you just need to address that. That is an issue. It doesn't really hold up. So you create your sequence instead outside. So if we look at the project here, we added some complexity here. Instead of just having the 3 sub-VIs and the main, we also now have created a type definition. This type definition is a test name, and then what step is connected to that step, then it's test name. So now we can just take this test name, and then pass it on to our report cluster here. At the end, we have a report that will take the cluster and throw it into whatever sort of report we want. But all of a sudden, we can see in code the order of our test cases here. In my mind, a lot better than the last one. So going to the state machine, yeah, that solves some issues, created some other issues, and eventually you want to go away from that and create some sort of, well, this is kind of state machine itself, but a different kind of state machine. So what we have here is that we got the measured current. That always has the AI1 as an input for us here. Then we have a power on, and then we have the power off. The only difference being that the input differs to that sub-VI. Right, so there's some development to be done here. We could do this better.
There's also a small bug.
There's bugs all over the place. You're going to find more of them. Yeah, where is it?
Your number 3 will have the log from all the other ones because you're not removing the log output. So you're not cleaning the report.
Oh yeah, yeah. So you need to rerun the program each and every time you.
No. Every time it runs,
yeah,
the last test will have all the results. of the previous tests.
Yes.
Because,
So it just builds on an array.
Exactly.
Yeah, so there's a lot of things to know about the system and how to handle it. But obviously, this is not where we want to be, and most organizations would want to move away from that. So the next one, we add inputs to our sequence. The only difference here is, takes a while before it shows up here. There we go. Difference here is that, all right, we have the test name, we have the test step that we want to run, but we add an input to it. So for the measure current, we always say AI1 here. That's the only signal we have so far. But for the power, instead of have power on and power off, we just have power and then have it off and on as an input. Then we sort of get some sort of an, I can't remember what that pattern is called, but you throw it in a task, it executes the task.
Template.
Through?
Templating. I think so.
Yeah, maybe it wasn't what I had in mind, but it's similar. Yeah. So small difference. We didn't add much complexity to this. We just updated the type def of the test cases. We made this part, the case structure, simpler, and reduced the number, the amount of duplicated code that we have here. So this is all good. I like this. Obviously, there's a next step. You don't really want to have your sequence hard-coded, right? You want to have it in some sort of a text file. I don't have it in a text file, but I kind of pretend that I do. So you see already here, now we have the number of sub-VIs is growing all of a sudden. We got 6 sub-VIs instead of 3. Because what's happening here is that, all right, we have one function, right, this just creates a test sequence, but we need to pretend that this one reads it from a file. But since this is being read from a file, we as a developer has lost control of what that is in that file. So for our system to have some sort of robustness, we need to validate the inputs of that file before we can start running a test system. So that adds a whole new part of the system that we're not just going to execute test cases. We also need to validate the in data to the test cases. That leads to more error handling, obviously. So what's happening here is that, all right, I take a test name, I say, all right, this is the power test case. We open this function here. Okay, this is a validate DUT power. If it's an off or an on, we're fine. If it's anything else, we get an error. So if someone would write on and then have a white space, this will throw an error. On the previous one, if someone would have written on and a white space, the system would actually have turned the power off, because it just looks for if the input is on. If it equals on, then it's going to set to on. So on white space will be off. That's a hard one to track down. So more robustness in the system. Much more complicated all of a sudden. I'd say twice as complicated because we got twice as many sub-VIs. Rest of the system is pretty much the same. Now, if you want to add a test case here, right, you need to create a new sub-VI for the test case. For example, let's say measure voltage. But you also need to create the validation for that sub-VI, like validate voltage inputs, and you need to update this part, and you need to update the validation part. And this is where software engineers start thinking, oh, we want to take the next step. And that's kind of obvious case for object-oriented code. Close that one, and we open the object-oriented part here. I call it simple factory. This is the code. It's lagging there. There we have it. So this looks very simple when you open it up. The complexity that we had in the previous one, it's all there. We all need it. It's just hidden somewhere else. So for that guy, that hardware engineer, opens up LabVIEW 3 times a year just to fix something in the test system. Seeing this is not going to make them happy. For a software engineer, seeing this is going to be, this looks good. So what happens here is that, right, we initialize the report. We have a factory here, a simple factory. There we go. That depending on your test step, again, you need to kind of fake that this comes from a file somehow. But depending on your test case, we load the test class. All those test classes will inherit from a test case base class. So this is the only place where you actually see the measure current class. Rest of the system, it only works on the base. So you initialize that, and then sorry, just gonna look at this as well. Here we have the set inputs of that class, and then there's also a validation of those inputs. And then we just execute it and then add to report as we go along. So looks very simple. When you look at this one, at the block diagram, it does not look very simple when you open up the project. We're going from 6 sub-VIs, well, to this. Oh yeah, you know. So we're doing the same task. Instead of doing it with 6 sub-VIs, we have all of this. And from a developer experience, from my kind of experience, I'm going to sit there and update this. This is great. Whenever I need a new test case, I create a new class, I make sure I put it in the factory, and that's all I need to do. I can use any of the other classes or use the base class as a template. I know that, all right, there are these 3, 4, 5 functions that I need to implement. It's all contained within the class. It's very obvious what I need to do. For the newbie, so much. We're going to take the next step as well. So what I did here is kind of the simple version of a factory. Let's say that a bit where Martin was, they want to be able to deploy new instruments on the fly. Let's say that, all right, we want to be able to send new test cases to the factory. All right, we're going to update the script, the test sequence. We want a new test case. We want to send this to the factory. We do not want to make a new version of the entire system. Right, then we're looking at the plugin architecture. And then we go into what Martin showed us just earlier, with how they load their instruments. So you go here, code not up yet. Let's go to Sweden first. Not there.
I don't know. It was faster and always.
So the code looks exactly the same from this point of view. The only difference is the factory here, where we dynamically load the classes that we want instead of having them hard coded in a case structure. There we go. So this is pretty much the bare bone version of what Martin showed you earlier. Here, just find the class on disk, load it, and then force it into being a test case-based class. Right, so with this, we can just send a new test case to the factory, ask them to put this class, this folder on this place on disk, and then you're ready to go. So is this good or bad? Software engineering that likes to do fancy stuff, it's great. For anyone that's going to look at this 2 or 3 years down the road when you move to India and trying to find out which animal you represent, someone else opens this and they're not going to be very happy. So what they see when they open up main is what's it come up? It's this, and they're going to figure out, okay, what happens really? They're going to open up the factory. You're going to see, all right, something weird is happening, and after a while, they're going to understand, all right, this is some sort of a dynamic factory. And then they're going to go into the project and see, all right, so what test cases do we actually have here? And they find nothing. It's just empty. You got the base class and nothing else. So all of a sudden, your project looks very clean. Your code looks very clean. You still have all the complexity that you had in the last project, where you had these 4 classes and maybe 40, 50, 60 different functions. That complexity is still there, only you can't see it. So would I go here? Sometimes, but most definitely only when I need it. So I've done it just because I thought it was cool and fun. I'm not going to do it again because it's cool and fun. I'm going to do it because it's needed. And I'm going to stay away from solutions like this if I don't need it. If this is a requirement, very good solution. If it's not a requirement, it's just going to be trickier for you to handle the system and keep track of everything. Any questions?
Which one of them are you using the most?
Well, we as I said, we use DQMH, so there's a lot of stuff around it there. So we've opted for ourselves to have the requirement on our colleagues that, right, you need to be proficient at DQMH. You also need to be somewhat savvy when it comes to object-oriented code. So we try to use barebone DQMH. Quite often we need to add some object-oriented code to it, like in a HAL, for example. I'm going to show you a little bit of an example later. But obviously, the system just having DQMH is going to make your project explode. It adds just doing a call or something like that, going to add 5 different functions for you. So if you're afraid of a lot of VIs, don't go for any framework at all. That's my suggestion. But the frameworks do help, and you need to feel at ease with knowing, okay, this is part of the framework. I don't need to care about that. I wish there were better ways in the projects to kind of hide that away somehow. But it's going to be in your face all the time. If I would send this to a customer, I would want to find out what customer that is. Usually when we build up the platform for the customer, we kind of sit down with them and try to find out, all right, what is the proficiency within this organization? What can we expect from them? And then we push code towards them that is a little bit about that, because we want them to develop and be better at what they do. But if you push that too far, they're going to receive the code from you. They're going to see that, all right, you built the system for us. We own this. We can manage this. And then 2 years down the road, they're going to open it and say, to just add some features. And if that is going to be too complicated for them, they're going to ditch that system and build something from scratch on their own. And that's going to be on the second level here. And then our job is wasted. I can show you a little bit on where we are in a project. Let's go here. This project is built on top of a code base that we have. We have a number of template projects using DQMH. And a colleague of mine started this a few years back. I inherited this project from him. We're currently finalizing it. It's a production tester. It's been a long project. So what you see here is you got loads of different modules. Some of them are kind of reuse modules that we have. Some of them specific for this project. What I highlighted here and expanded is the sequence handler. We're not using test stand or the simpler sequences. The customers tend not to want test stand sometimes because they just don't want to handle the licensing with it. And then we have our own sequencer that, fits the basic needs pretty much. So we've taken that sequencer can be used for, test system, can also be used for control systems and stuff like that. So we have a sequence execution handler class, which is the base class, and a test sequence execution handler that kind of inherits from that because we're running a test sequence here. And then here behind the black thing, we got the customer specific test sequence execution class. A lot of code here just for administrating these classes here. And down here in the function called handle step, that's where everything happens. So in this case, we pretty much implement all the test cases in there for the customer. New test case, we implement it there. I do need to update 2 other VIs when I add a new test case. Is this good? I would want to make each test case an object. Then whenever I create a new one, I know, all right, I need to create a new class inherits from this. And then it will be obvious for me that I need to do these 3 steps, these 3 functions in the class. My code would be neater. My project would explode. But if we get a junior developer and he or she is going to open this in 2 years' time, they'll be happy that we didn't. The customer kind of showing interest in owning this code and being able to maintain it themselves. They're building up their kind of proficiency within software themselves. So I will need to explain how this works for them. With this, I can say that, all right, you need to update this function, you need to update this function, and you need to update this function to create a new test. If I went to object-oriented, I need to tell them, all right, you need to create a new class and then they need to know what object-oriented code is. And mostly they are hardware engineers, and that even if you're used to it, it comes very natural. If you're not used to it, it's a kind of big wall in front of you when people start talking about object-oriented code. So what the code looks like today is pretty much like this. There's a bug in here as well. That we, whenever I need a new test case, I implement a new case here. Do all the tests, send the tests to report, or I broadcast it, and the report is listening to get the new test, to get the new results. So in here right now, I got maybe 30 test cases here. Some of them are marked with X because they're obsolete or they're not fully implemented. That would be a lot neater if I went with an object-oriented approach to this, because I don't have to have the not completed or the obsolete or the ones to be taken away, and would be nice to have maybe in here. I could also have code that actually doesn't compile if I went to object-oriented code here. Right, I just don't keep it in the project, and when I need a project, I drag it in and fix it. So for me, as a senior developer, I would want this to be object-oriented, but I do not think it's a good solution for the team that's going to own this code. So that's pretty much the conclusion that I have. That right. So how much architecture should you throw at your system? And as usually the answer, it depends. It depends on who's going to own the code, on your organization, who you believe is going to open this in 2 years and try to do any changes to it. Any comments, questions?
I have one.
Yeah.
The one you talked about with dynamic loaded classes with Martins.
Yeah.
Was that because you had issue, or was it because you know there's a special way of doing it? Maybe you had some extra.
No. The reason I asked is that the immediacy of the code, if you go to this project here, then you got the test steps and you got the test step space, and that's all you got. If you want to open a project and see and be able to read the code and step down and see right what actually happens deep down, you're not able to do that here. You lose that readability. You got no readability at all about the power supply that comes from Keysight. You got no idea. So you need to know that, all right, it says Keysight in the text file somewhere that's going to be loaded, and that means that I need to go into this folder and look at the test and the Keysight power supply class there, and that immediacy of the code is totally lost when you do this. Also, when it comes to the debugging, you cannot kind of put a breakpoint in the code unless you've been loaded that into your project. Or if you if you had already dynamically loaded the class, then I believe that it will show up when you click on the base class there. So if you go, for example, here for the execute here, this just opens the base class, and here you will only find some error handling saying that, right, you're calling an abstract method or something like that. Obviously, I haven't implemented that. If you go to the previous one where you had the kind of cheaper factory, I'm going to minimize all these. So open main here, and you go to execute here. Right, now you got all the different versions that you want here, and you can see them immediately. All right, so if this is the tower, this is happening. If this is in a test, this is happening. If this measure, this is happening. All that was hidden and not available to go with the fancier stuff.